In examples 9 and 10, we want to solve a system of inequalities. And again, we're going to be focusing on solving this system by graphing. To do that, we can flip back over to Desmos. And in example 9, we have y less than or equal to negative 5/3 x minus 5. And I put an extra equal sign in there. Let me get rid of that. And we can already see as we plot that, as we type in that inequality, it's graphing that first inequality and completing the shading for us. Then we have y is less than or equal to 1/3 x plus 5. We can see where those two lines intersect at this gray point, negative 5, 3.333 repeating. But what we're interested in graphing inequalities is representing all of the possible solutions, which means looking at those boundary lines. In this case, they both have or equal to statements. Points along those lines in the correct shaded area will be solutions, and also any point in the region where those shaded areas overlap. In this case, we have a region in red, if we turn these on and off. Well, we'll just look at it this way. We can see that that red line, we're shading everything below that and shading everything below this blue line. We're looking for that region of overlap, which would be this section of the graph. When we're asked to give one point in the solution set, we have an infinite number of possibilities. We just need to choose any point that's in this region or along those boundary lines for this region. For instance, we could choose the point -6, 0. That point, that xy pair, would make both inequalities true, but it also isn't the only solution. -6, 0 would be a solution. We could also say -5, 0. Again, any point that's in that shaded region. Taking a look at example 10, we can delete the work that we've already got here and graph these two new inequalities. Y is greater than -2x plus 5, and y is greater than or equal to (3/2 x plus 1. Now, actually, I made a mistake typing in that first inequality. That first inequality should be a strict inequality. So let me change that so that is strictly greater than. You'll see that Desmos automatically changes that to be a dashed line. And actually, let me make one other correction here. I realized how I put that equal sign is that I meant to hit a minus sign. So now we've got this region, or these two graphs. We have one of our boundary lines is a dashed line, since we have that strict inequality. The other one is a solid line. That means we could pick any point on this solid line, any point in this region of overlap, but we can't pick points along this dashed line since those points are the boundary, but not included as part of the solution. That means in this case we could pick a point like 0, 10. That point lies in that overlapping shaded region. It's not on that dashed boundary line, so that would be a solution to this given system of inequalities.